Hello people, welcome one and all to Jojo's Learning Club.
Hello guys, welcome back to my channel Jojo's Learning Club. So this is a continuation on the series electronic device circuits, and on this section we'll deal with the diffusion and diffusion current. This is actually a small video which just says about diffusion and diffusion current. Okay, so let's directly go to what is a diffusion. Diffusion is actually a natural phenomenon, the migration of charge carriers from higher concentration to lower concentration, or from higher density to a lower density, and that is called diffusion. So what is diffusion? It's a migration of charge carriers. Diffusion is mainly due to concentration gradient, that is dN by dx is the electron concentration gradient and dP by dx is the hole concentration gradient. You see that migration of charge carriers from higher concentration to lower concentration, that is called, the graph is showing about. Diffusion current flows only in semiconductors, right? We have no diffusion current in metals or insulators. In metals there is only drift current, but in case of semiconductors you have drift current and also diffusion current. In a semiconductor, diffusion happens because due to the unequal distribution of charge carriers. And in metal, why we don't have electron concentration is very high in metals, that is in the range of 10 raised to 28 per meter cube it is actually, and therefore electrons are arranged with equal distribution. Diffusion is also associated with the random motion of charge carriers to thermal vibrations. So now let's learn about the length of diffusion. Length of diffusion is root of d into z, where d is the diffusion coefficient of charge carriers and tau is the carrier lifetime or the average lifetime. Length of diffusion is the average length, since d is equal to mu into vt, L is equal to root of mu into vt into tau. So length of diffusion depends on diffusion constant of charge carriers, mobility of charge carriers, carrier lifetime, and temperature. Electron diffusion length Ln is equal to root of dn into tau n. Tau n is the lifetime, carrier lifetime. Hole diffusion length LP will be what? Similar to the electron diffusion length, just it will be in terms of holes, that is root of diffusion coefficient of holes into carrier lifetime. Electron diffusion density Jn of diffusion is equal to Q into dn by dx. Similarly for holes, the diffusion current density will be minus q into dp into dp by dx. Hole diffusion current, ip diffusion current, that is a hole diffusion current, is the diffusion current density into area. So the total current density in a semiconductor will be what? Total current density in a semiconductor will comprise both of current density of holes and current density of electrons. So where Jn is equal to Jn diffusion plus drift. So current density is actually made up of what? Diffusion and drift. So Jn, so diffusion, what it will be? Q into dn by dx, plus again drift, it will be, we already learned it in the previous chapter. If you have some doubts regarding the drift current, go back to the channel. It is discussed either in the part 2 or part 3. So n into q into mu n into epsilon 0 of ampere per centimeter square. So J, similarly for the holes, the current density of holes is like Jp diffusion plus diff current minus q into dp by dx plus p into q into mu p into epsilon 0. Drift current mainly depends on field intensity, and diffusion current mainly depends on the concentration gradient. So what are the major differences? Drift current mainly depends on the field intensity, and the diffusion current mainly depends on the concentration gradient. And as I said, we'll discuss more about the intrinsic semiconductors in the coming section. We'll discuss about detail with the crystalline structure about all these sections on the next video. Okay, until then, bye and have a nice day.